Have you ever thought about diamonds beyond their sparkle and price tag? What if I told you that these beautiful gems are about to become the unsung heroes of our technological future? Forget jewelry. We're talking about a revolution that could change everything from computing to medicine. Diamonds are, of course, famous for being the hardest natural material on Earth. This incredible durability is just the start. At their core, diamonds are simply carbon atoms arranged in a super strong crystal lattice structure. This unique structure gives them some mind-blowing properties. They're amazing thermal conductors, meaning they can pull heat away faster than almost anything else. They're also electrical insulators, but can be transformed into semiconductors. And they're incredibly stable and resistant to chemicals and radiation. These aren't just cool facts, they're the building blocks for next-generation technology. So where will we see these diamond-powered advancements? Let's start with computing. You've heard of Moore's Law? The idea that computer chips get twice as powerful every 2 years? Well, we're hitting a wall. Silicon chips in our devices are getting so small and crowded that they overheat. They just can't handle the heat generated by faster processing. This is where diamonds shine, literally. Imagine replacing silicon with a thin layer of diamond. Because diamonds are the ultimate heat sinks, they could whisk away all that excess heat, allowing our processors to run much faster and more efficiently. We're talking about computers that are not just incrementally better, but potentially hundreds of times more powerful than what we have today. This isn't science fiction. Researchers are actively developing diamond semiconductors. This could mean supercomputers that fit in your pocket in data centers that use a fraction of the energy they do now. But the applications don't stop there. Let's talk about quantum computing. Quantum computers promise to solve problems that are impossible for even the most powerful classical computers. But they are incredibly delicate. The quantum bits, or qubits, need to be kept in a very stable, isolated environment. Any tiny disturbance can ruin the calculation. Enter the diamond. Scientists have found that tiny imperfections in a diamond's crystal lattice, called nitrogen vacancy centers, can act as perfect, stable qubits. These NV centers can hold a quantum state at room temperature, which is a massive breakthrough. Most quantum computers need to be supercooled to near absolute zero, making them huge, expensive, and impractical. Diamond-based quantum computers could be smaller, more robust, and could operate right on your desk. This would unlock new frontiers in drug discovery, materials, science, and artificial intelligence. Now, let's zoom out to the world of energy and electronics. Our world runs on electricity, and we're constantly looking for ways to make our power grid more efficient. A lot of energy is lost as heat when electricity is converted from high voltage for transmission to low voltage for our homes. Diamond-based electronics could handle much higher voltages and temperatures than silicon. This means more efficient power converters for everything from electric vehicles to the entire power grid, saving enormous amounts of energy and reducing our carbon footprint. Your future EV might charge faster and go further, thanks to a little bit of diamond under the hood. The medical field is another area poised for a diamond revolution. Think about medical imaging and diagnostics. Those NV centers I mentioned earlier are not just great for quantum computing, they're also incredibly sensitive magnetic sensors. They can be used to detect the tiny magnetic fields produced by a single molecule or even a single neuron firing in the brain. Imagine a future where doctors can use diamond nanosensors to get a real-time map of your brain activity with unprecedented detail, helping to diagnose diseases like Alzheimer's or Parkinson's much earlier. Or what about cancer treatment? Tiny nanodiamonds could be used to deliver drugs directly to cancer cells, avoiding damage to healthy tissue. Their non-toxic and stable nature makes them perfect for these kinds of targeted therapies. They could even be used in medical implants, like artificial retinas, because they are biocompatible and won't be rejected by the body. Okay, so diamond-based supercomputers, room temperature, quantum processors, hyper-efficient power grids, and revolutionary medical tools. It all sounds amazing. But you might be thinking, aren't diamonds incredibly expensive and rare? That's the best part. We're not talking about mining these diamonds from the ground. We're talking about lab-grown diamonds. In recent years, our ability to create high-quality, pure diamonds in a lab has exploded. Using techniques like chemical vapor deposition or CVD, scientists can now grow flawless diamond wafers layer by layer. We can control their properties, make them into specific shapes, and produce them at a scale and cost that would be impossible with mined diamonds. These lab-grown gems are identical to natural ones at an atomic level, but can be made pure and tailored for specific technological uses. This is what makes the diamond tech revolution truly feasible. We are no longer limited by what we can dig out of the earth. The future powered by diamond is not a distant dream. It's a reality that scientists and engineers are building right now. It represents a fundamental shift away from the limitations of silicon and toward a new era of more powerful, efficient, and sustainable technology. From the tiniest quantum sensor to the vast energy grid, this brilliant material is set to redefine what's possible. The next time you see a diamond, remember that its true value might not be in its sparkle, but in its power to shape the world of tomorrow. Thanks for watching. If you found this glimpse into the future as exciting as I did, make sure to like this video and subscribe to the channel for more deep dives into the technologies that are changing our world. Let me know in the comments which diamond application you're most excited about. See you next time.